Hello students, so let's continue with the MCQs. The first MCQ today is, which of the following statements is true? Now when we look at the options, in each option they have mentioned power and focal length. In first case it is for convex lens, second case again for convex lens, third and fourth for concave lens. We know that concave lens has negative power and negative focal length. Because it has negative focal length, so it has negative power. And convex lens has positive focal length and positive power by sign convention. So when we look at the four options, convex can never be negative, so B is wrong. Concave can never be positive, so C is wrong. When we look at A and D, in A, convex has positive power 4 diopter and positive focal length 0.25 meters. And in D option, concave lens has negative power minus 4 diopter and positive focal length, which is not possible because concave lens, its focal length and power both are negative. So first option is correct, and we know power is 1 over F. So F will be 1 over 4, that is 0.25 meters. So A is the correct option. Now the next MCQ is, as light travels from denser to rarer medium, it will have A. decreased velocity, B. increased velocity, C. increased wavelength, D. both B and C. It means velocity and wavelength both will be increased. We know that for light we can use that formula for wave, V is equal to F lambda. And we know that when the medium of light changes, then frequency does not change, velocity and wavelength changes. And when it moves from denser to rarer mediums, its speed or velocity will increase and also its wavelength. So B and C, velocity, V is equal to F lambda, F remains constant. If V increases, lambda also increases. So B and C will increase, so D is the correct option. Now the next MCQ is, what will be the value of I if the angle of incidence I and refraction R are equal in a transparent slab? And we know that in a transparent slab, if I and R are equal, okay, so that is possible only when I is equal to 0 degree, because that is a case of normal incidence, okay. So here otherwise, because when in a transparent medium the incident ray, when the ray will enter, the refracted ray always it is going to bend towards or away from the normal depending upon the two media, but whether it is entering from denser to rarer or rarer to denser. Only in one case I and R will be equal, and that will be when each of them is equal to 0 degree. That is a case of normal incidence. So B is the correct option, 0. Now the next MCQ is, a lens of power minus 2 diopter is combined with a lens of power 3 diopter. The focal length of the combination is. Students, remember that whenever two lenses are in combination, the net power of the combination is the algebraic sum of the individual powers. It means P will be P1 plus P2 here. So P1 plus P2 means minus 2 plus 3, that is 1 diopter. So P will be the effective power of the combination. So the effective focal length will be 1 over P, that is 1 over 1, which is 1 meter. And here 1 meter option is not given anywhere. In A it is minus 1 meter, although we get power 1 diopter, so focal length will be plus 1 meter. So none of these is the correct option. Now the last MCQ is, if an object is at 2f in case of a convex lens, image is necessarily at. We know if your concepts are clear, then I don't think so you should have any difficulty in choosing the correct option, because when the object is placed at 2f, image is formed at 2f behind the lens, convex lens. So B, 2f is the correct answer. It is similar to the case that we have in concave mirror, where an object is placed at C, center of curvature, image is formed at C only. Real inverted same size image. Even in this case, Real inverted same size image is formed at 2f, but in this case it is behind the lens, and in mirror, concave mirror, it is in front of the mirror. Hope you have understood the MCQ, students. So we'll continue with the MCQs in our next video. See you, students. Goodbye.